Okay, I'm recording. Okay, I might be live. I think I am live. Yay. Okay. So I'm here. Um, Welcome to the stream. My name is Kent Quirk. I am here to solve Advent of Code. Today is day 1 of Advent of Code. Since I'm on the east coast of the United States, I can't jump on at midnight because I'm not up that late. That's the time that Advent Code is released. So instead, I'm doing them later in the day of that release, but later on. I'm trying to focus on solving problems maybe in a way that is less about speed to solution and try to go for a bit of quality on the solution. I'm mostly going to be using the Go programming language, but I may sometimes have some help on the stream. So when I do, I hope that we may delve into other areas. But the idea would be to teach a few things about code quality, software engineering, algorithms, computer science, that kind of stuff. So I will divert sometimes and explain if I recognize an algorithm or recognize a reference. I may talk about that for a bit. So this won't be how quick can I get a solution out, because very often, like you can whip an answer out to these things in a lot of cases, particularly early on, within a few minutes. Say in a language like Python or something like that, where you really can quickly sort of just throw something together and get an answer. But I'd like to do it in a structure that is kind of maintainable. I will be posting all of the results on a GitHub repository. I haven't set that up yet, so it may be tomorrow night. I'll like tell everybody where that is, but it's going to be on github.com/kentquirk/AOC 2021. I just haven't pushed anything to it yet. So, I generally try to reserve really thinking about the problem for this stream itself. So generally, when I look at it on screen, it's new to me as well as to you. Oh, well, and of course, you have my screen already in front of you. So what I've done, let's start talking. You're looking at my editors over here, my console terminal window here, and the browser pointing to Advent of Code. I did set up a Go project. I actually also have a main.py in here in case we end up writing something in Python. But a Go project set up basically with a template to just basically make it easy to get going with like reading data and that kind of stuff. I'm using, if you look at my Go mod file, I'm using Go 117, which is the current release, the current mainstream release of Go. Go 118 is coming soon, and it's going to have some generic stuff, which I haven't really had a lot of time to look into. And I know some of my friends and coworkers are doing this stuff with generics just for the fun of it. But I'm going to stick with 17 for now. Maybe later on the team, in the projects, I'll do something more. But for now, let's do AOC 2021. We're going to call this module Day01. And we have we're just going to be writing a main project. In terms of Go modules, this is just a main command line utility, and I'm just going to be creating a set of parallel directories. So, day one, let's find out what it's about. Here we go. All right, I'm not going to read every word aloud because I'm presuming anybody who's following along can do that. But let's take a look. You're minding your own business on a ship. Now you're inside a submarine. And I know if we're going to do a lot of submarines this time, I'm going to say subroutine instead of submarine many times. So it goes. It's covered in Christmas lights, and we're going to need 50 stars to crank it up. So, yep, that's our goal. We're going to solve all 50 puzzles by the end of December. So, each puzzle grants 1 star. All right, so here's our problem. Submarine drops below the surface. It performs a sonar sweep. On a small screen, you see a puzzle input. Each line is a measurement of the seafloor depth. And we have this. So we have a little sample data. And what I always like to do is I take this chunk of sample data, I copy it, and I put it in my input sample.txt file. So that's my sample. Can save that. And we'll change this to sample. And so now I can read that file, and just let's make sure that we know that it actually just compiles and run. Right now it's just going to split the data on new lines and print the result, print the first result. So go run main.go. Printed 199, which is the first value in that sample. So great. So our compiler works, our system works. All right, so now we have to find how quickly the depth increases. Count the number of times the depth measurement increases from the previous measurement. How many measurements are larger than the previous measurement? So we just need to do a loop over this data and just count increases. And they say basically the first one we ignore because there was no previous measurement. So we are going to write a func Day01A, which is and it's going to accept an array of string. Data. And return an integer. So, now we can't just do a range loop over data, because if we did, then what would happen, by the way, that's a slice. I tend to use the word array because I grew up with that term, but in Go land, that is a slice of string, which is different from an array of string. But if we just did a range over data, then we'd only be looking at one element at a time, and we'd look at all of the elements. But what we want to do is look at pairwise things, so we're better off using a numeric increment. So we're just going to do for int I is 0, I is less than len of data minus 1, I plus plus. So that's the loop up to the item before the end. And then we are going to diff is the, and again, this stuff I'm writing pretty explicit code, but diff is going to be oh, we have to turn these into numbers. So n equals, or n1 equals strconf dot I to a of data of I. And actually, since we know this is going to be numeric data, I'm not really going to just ignore the errors. And 2 data of I plus 1 and diff, so it's the larger than the previous. So diff is n2 minus n1 and we need a count variable. Count equals colon equals 0 and count if diff is greater than 0, count plus equals 1. Count plus plus is fine and go. Sometimes Python creeps into my thinking. And then we can just return count. So far, instead of printing lines of 0, we are going to print Day01 of lines. And so if we save that and run it, we should see, whoops, what did I do wrong? Int. I didn't need to define that. Okay. A to I. There we go. All right. Let's try it again. So it printed 7, which is the example. So now we got to get our puzzle input. And we'll copy all of that. And we will paste it into our input.txt. 2000 values. Save that. Run it again. Whoops, I forgot to change my input. It's no longer the sample. 1477. So we're going to put 1477 into the answer box. Ta-da! We got a star. All right, let's continue. Too much noise in the data. So now we have to consider sums of the 3 measurement sliding window. So the first measurement, okay. $199, $228. Their sum is 607. The second window's sum is 618. All right, so we're going to go back to input sample just to make sure we get this right. And we're going to create a day 2 function, which starts out pretty similar. And we're going to call it day, I'm sorry, it's not day 1, it's day 1B. Actually, I'll leave that one as A and make this one B. And so we're using triples, and my inclination is to just do it manually. This was kind of inefficient though, because I'm doing an A to I for each value every time, which means every number in the first round, every number got A to I twice. This one, every number will get A to Y 3 times, except for the ones at the ends. Or I could do a little bit more elaborate of sliding the values I've already calculated. So we're going to change this to -2, and we're going to do n3 is this. So, oh, we have to preserve the sums for the window. It might be easier to do this as a quick little sorry. Might be easier to do this in multiple steps. So in other words, instead of doing the A to I's inside the loop, I could do the A to I's in advance and pass in an array of, or a slice of integers, which is the values in the data set. So what if I change this here to int, and then oh yeah, let's make so we're going to, for every element in the lens, we're just going to do ints, oh, normally I wouldn't ignore errors, but in this thing, I'm pretty confident that I can. So I'm just going to do this. I don't need L here. Wait, why is this yelling at me? Doesn't like something, but it's not giving me an answer. Oh, because it wasn't being used, maybe? Minus. Okay, and then, so that should still work. I'm just going to comment this one out for a minute. And save it. It still claims there's an error here, but it's not telling me what the error is, so I'm just going to run it and just see what happens. Non-name ints. on the side of colon equals. Oh, I wish the error had shown up in my editor. I don't know why it didn't. Okay, that gave me the right answer. So now I can uncomment this, save it, and so I can say sum equals, basically I can take these three values, join them together, and this is equals 2 here, and then all right, instead I'm going to do it this way. Copy, we'll create a last sum. Last sum equals data of 0, 1, and 2. And that needs a colon. And now and then instead we're going to do it this way, starting at 1, because we have last sum now for the first element, and then data, we're still going up to the end, which is data minus 2, and my sum is now the sum of those three, and if sum is greater than last sum, we increment the count. And then we have to update last sum. So last sum now gets sum. And this time on the sample data, we should get 5. Oh. Seven and 5. So I'm happy with that. So now I'm going to say, take the input data, save that, run it again, 77 and 1523. So that is the answer that we think we need. And we did it. So we solved it. And we are good for today. So we successfully solved the problem. First days are always pretty easy, fun to do, and I'm not going to belabor the point anymore. We'll call that a night, and I will post this also on YouTube for those who are interested, and we'll solve the next one tomorrow. So hope to see people back here tomorrow night, and hope you all have a good one. See ya. Bye.